Thank you for joining us and welcome to this live virtual open day session for design engineering. Just a couple of housekeeping points before we begin this session. So this session will be recorded. So if you have missed any points or you would really like to watch the recording again, then you will be able to do this after the session. You can also use the Q&A button as well to ask any of your questions, and these would be posed to our panel and also our ambassadors that have joined us today. If you would like a question to be answered, you can choose to like it and it will be upvoted. We will try to answer as many questions as possible, but as this is quite a popular session, this might not be the case. So we will try our best to answer as many as possible. But without further ado, I'd like to pass over to Dr. Sam Cooper, who will then get the session started. Thank you so much, Sam.
Thank you very much, Bo. Okay, good afternoon and welcome to the admissions talk for the Dyson School of Design Engineering. My name is Dr. Sam Cooper and I'm the admissions tutor for the department, which means it's my role to help build a system to select which high school students come and join us every year. I'm also an associate professor in materials design and energy science, which means I work on things like batteries and fuel cells using simulations and machine learning. And I'm also the course leader for first year mathematics. So if you do come and join us, I'll be the one teaching you maths in your first year. So here we have a beautiful view of the South Kensington campus of Imperial College on a lovely sunny day. And everything ringed in yellow is all part of the Imperial campus. Imperial's got two other campuses as well, one in northwest London and one south of South London. And this blue building that's just come up on the right hand side is the Dyson School of Design Engineering. So here we are closer in, and you can see to its left, the grey pillared building is the Science Museum, and to the right is Imperial Road leading onto the rest of the campus. So this used to be the meteorological office and post office. And about 6 years ago, it was purchased by Imperial College and turned into the new department, Design Engineering. In our department, we've got wonderful things like research labs in the basement. We've got hack spaces across campus, cafes and breakout spaces where our students spend endless hours working on their personal passion projects or courseworks. We've got a beautiful old wooden library, boardrooms for meetings, workshops with renovated new spaces for electronics, and everything you'd need to deliver a world-class engineering education. So what is design engineering? We like to think of it as the fusion of design thinking, engineering understanding, practical experience in a culture of innovation and enterprise. Well, those are nice words. What do they mean in practice? So here are some examples of projects. Customize adaptive prosthetics, sustainable habitats, robotic systems for disaster areas, personal data security, spatial audio for world building, educational children's games. Now, that, I think you will agree, is quite an eclectic mix of things, a very strange mix. What do they all have in common, everything listed there? Well, all of them require a profound level of engineering understanding. You will need to know how to do electronics, mechanics, robotics, mathematics, coding, mechanical design, 3D printing perhaps, etc., etc. All the classic engineering skills. But all of them also require you to have a deep understanding of how humans behave and how they interact with the products that you produce. So it's not just about products in terms of physical things or what we call artifacts. It's also things like systems, services, experiences. So, for example, of course, Google and Facebook are two of the largest engineering companies in the world today, but they don't principally make physical objects. They, of course, make systems and services. So the fact that you can go and search on Google or communicate with your friends via a social media website, these are not things that you can reach out and touch, but they require a huge amount of technical understanding. But in addition to the technical understanding, you have to also understand things like economic function, social function, aesthetic function, latent function. All of these things have to come together at the same time in order for you to deploy successful products. So we have 4 different student experiences. We have a 4-year Masters of Engineering, or MEng, in Design Engineering, which I think is what almost all of you will be interested in hearing about today. We've also got 2 joint 2-year master's courses with the Royal College of Art, which is just across the road, called Innovation Design Engineering and Global Innovation Design. Those are graduate courses, so for people who already have a degree in something. And we, of course, also have our research PhD students. So all the academics like myself will have a small team of PhD students with whom they do their research. To give you a sense of what you'll be doing throughout the degree, I've broken down the whole learning program into each of the modules. So we like to think about the degree broadly in 2 parts. The first 2 years lay your foundations, and the second 2 years allow you to explore them by building larger projects. So in the first year, you've got your introduction to design engineering, as well as human-centered design engineering, so bringing the design skills up to scratch. But we're also principally laying out the core foundations of your engineering skills. So mathematics, 2 computing modules, production materials, mechanics, and electronics, all the classic engineering modules. In second year, we start to expand your design thinking with working in organizations, sustainability, and industrialization. But we're actually also principally laying out your engineering skills again. So we've got data science, mechanics, finite elements, thermodynamics, gizmo, and electronics too. Gizmo is a module where you get a very, very open brief indeed, but with some key constraints. So it could be make whatever you want, but it has to be made out of cardboard. It has to have 10 different joints and it has to move in a particular way. And students tend to absolutely adore this module because you end up with endless weird and wonderful creations at the end. And if you go to our YouTube channel, you can see a 30-second clip of all 90 of last year's students online. In year 3, we now start to have a bit more flexibility. So we explore innovation and enterprise. We have a large group coursework module called the Design Engineering Futures, which lasts 2 full terms. In that module, you will think about technology and societal trends over the next 20 years and what the implications could be, what that future might look like, and then think about how you could design some kind of intervention that would interact with that space in a positive way. We are going to be looking at optimization and robotics. So these are 2 very advanced technical modules. And the key thing about both of them is that in order to engage at all with either optimization or robotics, you already have to have a lot of the foundations in place. So you're already, if you're going to do robotics, going to need to understand computing, mathematics, electronics, manufacture and dynamics, mechanics. All these things have to already be in place. You've then got 2 types of elective module. One elective module is from any department or a very wide range of departments across the faculty. So you could go, for example, to the bioengineering department and learn about how biomechanics interacts with design. And you can also do an I Explore module, and these modules are sort of pass-fail, so they're not for credit, and they're to deliberately try and broaden your horizon. So perhaps you could do philosophy or a language. Then in third year, at the end of the second term, instead of having an Easter holiday or a summer term or a summer holiday, we then insist that you go away for a 6-month industrial placement. On this placement, you can do almost anything you want. It is up to you to apply to a company that you are particularly excited by and inspired by. We will help you in any way we can by trying to help you write your CV or practice for interview, etc. But it's ultimately up to you, and some students end up applying to 10 or 20 companies before they get something they want. And this is, of course, very realistic in terms of the real working world. When you come back from industrial placement, we then have your 4th year, which only has 1 compulsory taught module, which is the enterprise rollout module, which is very much about how do you turn your concept into a product or your product into a business. You also have a master's project, which is throughout all of the year, you will team up one-on-one with a professor such as myself and work with them on a particular project, and it's broadly of your choosing. The professors will also propose some projects which you might choose from. But if you can come up with a cool idea, you pitch it to a professor and they'll say, okay, I'll work with you on that. You then also have 4 more elective modules, and we hope that your placement will have given you a sense of what it is you really want to do with your career, and then you can make informed choices about how to invest your remaining learning time. We have a very strong emphasis throughout the degree on learning by doing. So here is the coursework for the Electronics 2 module. It is a balancing, dancing robot. So you can see this little robot's got 2 wheels, so it would fall over, but the electronics on board are constantly measuring the acceleration of the system and allowing it to stay balanced upright. It's also listening to the sounds in the environment, and it will dance to the beat when it measures one. We have courseworks really throughout the module, throughout the degree, and they're really at the very core of our learning program. So at least 80% of all of your final marks in the degree will result from coursework-based assessments. And this was a coursework from Electronics 1 several years ago, where students had to build a robot that could detect magnetic signals, vibrational signals, sound signals, and light signals. We'll have many opportunities throughout the degree for you to showcase your work at exhibitions. We had our school open house as a part of the Great Exhibition Road Festival only a few weeks ago. And we will invite in academics, we'll invite in industry experts, and you can invite your family and friends to come and look at all the amazing things that you've created. We also really stress synthesizing knowledge. So here is some coursework from the audio experience and design module. And what you can see, this beautiful multicolored object in the top right hand side of the screen, is a representation of the human hearing system, so the human cochlea. And what the student has done is used their prototyping skills, their manufacturing skills, their electronic skills, and their coding skills to create this artifact. And then on top of all of that, they've used what they've learned from the audio experience and design module to represent how sound works and how it's represented inside a human mind. We have a strong emphasis on robotics in the department. So these three robots represent the three different robotics professors that we have. Top right, you've got a sort of gripper, and this is about the topic of manipulation. And one of our professors focuses around this topic, which is absolutely critical for industry at the moment. So we have, for example, top UK tech companies like Ocado, who have huge robotic systems for sorting and arranging your shopping in a gigantic matrix structure that allows, at the end, two boxes to come next to each other, and a human will grab a box of eggs or a carton of juice or a bouquet of flowers and place it from the stock box into the delivery box. That final task of picking from one box and moving to the other is actually extremely complicated. Think of the robotic hand that you would need that could pick up all the different soft and hard, weak and strong objects, heavy and light, without damaging them or damaging it itself. So this is a huge theme in robotics today. On the bottom right, we've got a little spidery thing, a relatively friendly robotic spider. And this is one of our professors who focuses on biomimetic and bio-inspired robotics. So trying to understand how nature, through millions of years of evolution, has solved various complicated real world problems. Can we learn from that and use some of the same principles to make robotics better adapt to its environment? And on the left hand side is a new concept for industrial robotics, which is that rather than having a custom robot for every system, you have a generic robot that you can mass produce and use it on production lines, and therefore massively reduce the cost. But in addition, it's usually the robotics engineers that are more expensive than the robotics if you want to make your factory automatic. This robot has the advantage that you can just grab it by the hands, show it the task directly, and it will then have learnt that and repeat it indefinitely. Throughout the degree, of course, you will have to write up your ideas into reports, but we insist on a very high quality of graphical communication. So all of the rigorous content must be there, it must all be cited, all your graphics and figures must be correct and robust. However, that's no excuse for it to be boring. And this is one of the student groups from my master's project, or from my futures project last year, exploring the impact on various machine learning algorithms on democratic processes. Now I'd like to show you Hypnos, which is one of the master's projects I supervised the year before last. So it's this handsome little light fixture beside the bed. So what the student was looking to do was explore sleep health and sleep well-being. So they started off by doing a review of the scientific literature. And they then thought, right, okay, in the sleeping space, what are all the things that I can measure? So clearly you can measure light, you can measure sound, you can measure humidity, you can measure temperature, you can measure the amount of wind speed. What are all the things that you can change? Well, in fact, you can change light to a certain degree. You can change sound to a certain degree, also temperature. How can you use all this information and actuation potential to improve someone's sleep health? So the student, thinking about the key constraints of time and resource in this project, then went out and prototyped a device that could do some measurements and make some actuation. They then used their data analysis skills and machine learning knowledge to extract information from the recorded data. And then they would use their software design skills to inform the user the next day of what actions they could take to improve their sleep health. We have, as I mentioned during the module descriptor, we have a compulsory industrial placement, and we've now sent 3 years worth of students out to industry. And I, as a personal tutor, have to go and speak to the companies and say, how is the student getting on? How's it all going? And I cannot overstate just how delighted industry always are with our students. And the key thing that they say differentiates design engineering students from their engineering peers is just how ready they are to deliver on projects. So many, of course, there are many wonderful engineering degrees around the world and at Imperial College, but what design engineering seems to do very well is by constantly encouraging you or requiring you to deliver on technical projects on time to budget, you have a great deal of experience of getting things done, which is a trait that companies really enjoy. So here's a short, very short list of some of the internationally known companies that our students have gone for placements at. I'm sure you've heard of them already. We've also got a few graduate success stories. So these are some companies that have spun out of our graduates. So this is Qbot, a little robot that goes under the floor and sprays insulating foam above its head, which would otherwise be a job done by a human in a sort of quite dangerous and cramped space. This is Petit Pli, which is a solution to the fact that little children are some of the world's worst polluters because they grow so quickly and then their clothing and fashion ends up in the bin and ends up in our oceans as microplastics. These clothes use a concept, an origami-like concept, in order to enable the clothes to grow with the young child. This is Bare Conductive. It's a electronically conductive ink, which allows you to draw electronic circuits directly onto paper, which of course could be used as a teaching tool, but also companies are interested in using it to make things like packaging come alive. So you can imagine you've had an object delivered in a box, and when you open the box, by having a circuit broken that was otherwise connected using this ink, you can have a light come on inside the box as you view your product. So if all of that sounds like it might be the right place for you to come and learn, then what you need to do is get an A star in mathematics and 2 A's in your other 2 subjects. They can be any subject, but of course we do have preferences. So we prefer DT to geography, we prefer computing to religious studies. But if you are passionate about one of our non-preferred subjects, that's fine. We would like you to make a case for it in your personal statement, very briefly. And of course, if you go to our website, you can find out the scores necessary for all the other international qualifications. And if you can't find it there, please get in touch with us directly, design.engineering@imperial.ac.uk, which will be left up at the end. You will need to write a personal statement. You, of course, have to apply through the UCAS process. In this personal statement, we want you to differentiate yourself from your peers, of course. We get lots of people apply. So we want to show not just that you love engineering and played with Lego a lot as a kid and have read a book. It's just not enough. You want to do better than that. What we are looking for is for you to show that you have perhaps learned new skills, taught yourself skills above and beyond what was necessary at school. You have maybe used those skills to design and make things in the world. Could be products or could be an app or whatever. And ideally, then you've then taken the things that you've made and then you've put them out there. So maybe you've entered them into a competition, or you've used them as the basis for an activity in a society or something that means that you've stood behind them and said, I've made this thing. What do you think about it? We don't have an admissions test, but we do have some activities during our interview. And the interview will cover technical topics, design topics, and goodness of fit. College-wide English language is required, of course, but there's no need for ATAS. Last year, we had around 700 people apply. We invited about 300 of those to interview. We make about 170 offers. And of course, because of the grades that we require, only about 90 of those students meet the offer. And that's what we expect to be the case going forward. So we have a total intake of about 90 to 100 students each year. Interestingly, about 45% of those students are female. Now, a comparable engineering department, for example, mechanical engineering, which is just across the road, still only has about 15% female students. We don't know necessarily why we've got such high numbers of female students, but we're absolutely delighted and want to keep encouraging this trend. About 60% of our students are from the UK, 15% from the EU, and 25% from the rest of the world. And if you graduate from our degree, you will get an MEng, so a master's level qualification in engineering, which is exactly the same as all of the other MEngs from all across Imperial College engineering faculty. Our degree has been accredited by the IED, the IMechE, and the IET. What does that mean? Well, from the outside, perhaps not much, but what it means is these venerable, long-standing institutions whose job it is to go to engineering programs around the country and check that the material that is being taught is worth being taught and the certificates that the students received is worth the paper it's printed on. They've all come to us and said, we think what you're doing is what we need, but they've said much more than that. They've said that we think what you're doing is very much aligned with what we think modern engineers need to know. And that goes back to what I was saying before about the strong emphasis on deliverables, i.e. coursework throughout the degree. Our students are really ready to do things as soon as they get out in the world. So we hope that our program is bridging this gap between engineering, design and business, meaning that our grads are equipped with creativity, enterprise skills and industry experience, ready to get straight out there and change the world. We've already had people, of course, graduate in 3 different cohorts, and they've gone off and worked at various world-leading companies, as you'd expect. And we have an extremely strong student society, DesSoc, who make sure that some of our grads come back and talk to us about the amazing things that they're doing. We are, of course, part of the Faculty of Engineering at Imperial College London, and you're probably aware that Imperial, of course, always does very well in the world rankings in terms of quality of its graduates. And with that, I'd like to thank you very much for your attention. Please feel free to get in touch with us, design.engineering@imperial.ac.uk, or you can contact us on Twitter @ImperialDyson. And we now have some time allotted for questions and answers. I have 2 students with me today, 2 of our undergraduate students from the department, Amelia and Hamza, and I will be pushing questions to them if I think they'd be better placed to give the answer. So please go ahead and put your questions in the Q&A. I'll stop sharing my screen now, and we can start the process of letting you know what it's really like to study design engineering. So what's the difference between mechanical engineering and design engineering? I'm tempted to answer that myself, but maybe I will push this to Hamza as our first one.
Well, so I'm a first year student. I've just finished my first year. I've got a lot of friends on mechanical engineering, and I think the biggest difference between what we've done this year is, variety. The variety on the design engineering course, I think, is unparalleled at any other course I've heard about. And the other thing that seems to be a common trend is that the design engineers seem to have more fun with what we're doing. We've got a lot of projects. It's a lot more enjoyable. Unfortunately, the mechanical engineers, everything's still examined on paper, closed book. They just don't get the same enjoyment and excitement out of their work that I'd say I would.
Great. Well, I wouldn't have been allowed to say that, but can't argue with it. Amelia, any thoughts to share?
Sort of similar to Hamza. When I first looked at the course, the accreditation for MEcEng and DesEng were the same. So from my perspective, we were getting sort of industry was still wanting what we have as well. Realistically, in terms of like what you'll be taught, mechanical engineering will have more of a depth. So for example, they will have in thermofluids, they'll go much more in depth probably than we would. You still get a sufficient working knowledge, but then you'll also be taught other things, such as you might be able to go into more psychology-based things if that's your interest, or you have the opportunity. So you have the opportunity to really explore into what you're interested in. So yeah, I'm a second year student, just finished second year, so the year above Hamza. And next year we get to choose an elective, and some of my friends are going in to do advanced industrial design, whereas I'm going to go into machine learning. So you can really tailor your experience of what you want to be taught a lot more in design engineering than mechanical engineering, at least how I perceive it. So if you want to go more technical, you can, but then if you want to explore a creative side, you also have the opportunity to do that.
Fantastic. Thank you both for those answers. I could perhaps add that a little bit as well. I actually studied mechanical engineering at Imperial, so I actually really know what both courses are like. And of course, the mechanical engineering course is a fantastic course. It's a world-leading mechanical engineering course. However, as Hamza said, you go into a bit more technical detail about some classic engineering topics, a bit more mathematics, a little bit more mechanics, a bit more thermodynamics. But of course, if you're going to go for that little bit more depth, you miss out on that much more breadth. And what we've heard from lots of industry is that they really want engineers who understand just how broad the skill sets needs to be in order to deliver on modern products. Now, of course, you will always need people who have an extreme amount of depth on just thermodynamics, and that's what their career is going to be about. But you have to think about whether that's going to be you or whether you'd like to have a very broad understanding, especially at this early stage of your career. There's always time to specialize later. Something in addition to that is that with my research in simulation machine learning for energy storage, I'm probably one of the most technical researchers in the department. And I still don't use all of the mathematics that I learned during my undergraduate degree, which is a very strange thing to realize. Okay, we have a question here. Can you go into academia, for example, to do a PhD with a DE degree, or is it not a traditional academic enough? You can definitely do a PhD after design engineering. We thoroughly encourage it. But of course, most of our students go off into industry as they should. But we've already had 3 of our undergraduates come back to the department and stay on with the department to do their PhD. To the students, Amelia, you've already touched on this a bit, but why did you choose design engineering?
So for me, I took my A-levels really choosing what I was passionate about, and that was both having so the A-levels I took were maths, physics, psychology and art, so quite a broad range, because I feel like if you are someone who is really interested in really technical stuff but then also want to be creative, there's not too many things that you can go into, and a lot of people I've noticed in design engineering are actually pushed to do architecture, which isn't necessarily what people actually want to do. But I heard about this course, came to the open day, and really sort of like a light bulb moment that this was pretty much the only course that I could find that really let me have some creativity, but then also I wouldn't personally feel satisfied if I wasn't sort of mentally being pushed and being able to, use maths and use physics, which are both subjects I'm passionate about. So yeah, this was the exact mix of both creativity and technical knowledge.
Fabulous answer, thank you. Hamza.
So the A-levels I did were maths, further maths, design technology and physics. And it was, I think, year 11 where I decided that engineering was what I wanted to do. The problem for me was that most engineering courses seem too restrictive. I really like the idea of being, if you like, your one-stop need for any engineering solution, someone capable of at least making a start on any problem and getting close to a viable solution. So I didn't like the idea of just having skills in electronics or just mechanical skills. So for me, it was that I was looking at general engineering courses and design engineering. And for me, this course was just different, special. I think the fostering the creativity is a really beneficial thing. Most engineers aren't great designers, and we learn why on the course. You learn to be better with those sorts of things, but there's still plenty to satisfy anyone there who's just very passionate about just maths and physics. There's still plenty to keep you happy. So
absolutely. We've got, do you prefer physics as an A-level subject, and is computer science preferred to physics as an A-level subject? So yes, we prefer physics in the sense of it's one of our subjects that we think is relevant. It would be treated equally to computer science, but I think I can say with confidence in terms of what will be more helpful once you've arrived on the degree, computer science would probably have the edge. I think there's not much doubt about that. But we'd be delighted for you to take either in terms of our admissions process. Lots of the course seems very mechanical or typically engineering based. How much room is there for design / a larger focus on UX, form, etc.? Maybe Amelia, you could have a go at that one.
There is plenty of room to explore design in UX. So even in the modules, so Sam mentioned before in Gizmo, that's one of the first modules. So that's one of the first modules that you really get to combine everything that you want to. And it is a complete open brief. So for us this year, I don't know if it will change for Hamza's year, but we had to make an electromechanical system that had all the electronics. We had to do the coding for it, but it had to be made out of primarily plywood. And you had people doing anything. So some people made these gorgeous sort of trees and flowers that lit up and expanded. So you have a very technical basis, but then these gorgeous looking things. Whereas I went a bit more playful, and I made so from Squid Game, I made a red light, green light game, which you could play and it would detect what you're doing and spray you with water if you lost. So there's a lot of room to be creative and do UX and UI. And also you'll have to probably do a lot of portfolios throughout your time in design engineering. You do a lot of, visual presentations. So if there's anything about feeling like you're going to be stifled in creativity, there is certainly a lot of room. And even in projects, you'll naturally take on different roles. So you might have someone in your team who's very strong in coding, and so they'll take the lead of doing that. Or you'll have some people who are, very design based, and they'll take over that role. So you can really find your path in design engineering.
Excellent, Amelia. Hamza, anything you want to add to that?
I don't think there's much more I could say other than obviously Amelia has more experience than me, but yeah, it's been 1 year, and I think you already noticed that the people who are thriving the most are those that have a good mix of creativity, but also a hunger to learn and, take on all the technical aspects of the course. But you need both in order to really enjoy the course.
Excellent, thank you. Okay, does 4 A-levels look any better than 3 when applying? So yes, it does during the application process, but we almost always will typically make an offer for just 3 subjects when it comes to the offering stage. So we're delighted and impressed to see 4, but when it comes to offer, we'll do 3. That's driven by the fact that obviously lots of schools don't offer the opportunity of teaching for 4 A-levels, for example, if the student were to choose to do further mathematics. So we want to try and be as accessible as possible. Would IB Business be helpful for the course? So for all sort of module topics, you're welcome to just drop us an email, design.engineering@imperial.ac.uk, and we can clarify for you for any topic in any space. My daughter will start year 11 this September, but she has already made up her mind to do DE. She wants to know the opportunities for summer workshop availability at this level and later in 6th form as non-contextual student. That is something I would also say probably drop us an email about. There are certain summer schools available, but they are often booked up very fast and advertised to particular groups. So drop us an email and we can let you know what opportunities there are. Are the robotics modules shared with MEng computing, visual computing and robotics course? So not that I'm aware of, no. I'm not sure whether that's one of the elective modules that you can take across the faculty, but in general, every module that we deliver, for example, first year maths, although there's a first year maths course in every department, this is DE first year maths, and it's been custom designed just for our students to make sure that all the topics tie into somewhere else in the rest of the degree to make sure it's worthwhile. I've got some very pleasing nodding going on from Amelia and Hamza, which hopefully suggests that they've found that the maths that they did tie in somewhere else later on in the course. Amelia, have you found any bits that were totally useless yet, or some bits have tied in?
I was about to say matrices, and I realised that we did them in solid mechanics.
Okay, good.
Perhaps
Good.
we haven't done.
They'll be coming up lots in machine learning, I suspect.
Yeah, it will be. Perhaps a dot product. I don't think I've used a dot product since then.
Okay, that'll definitely be coming up in machine learning as well. Machine learning is basically just linear algebra in disguise. Okay, what have we got? What else have we got? I think, oh, here we go. Yes, we've got, would getting the minimum entry points guarantee me an interview? No, it would not. So we build a combined score of your predicted grades, your personal statement, and your reference letter, and we bring all of that information together and we give you a score. We are then looking to run about 300 interviews, and so each time we have a pool of interviews, we'll keep offering the top scoring students a place, and we would ultimately end up doing 300 of them. But that means that there is nothing that you can do that will guarantee you an interview other than being a student from a widening participation background. But that means that if you do have the things already that we've asked for, you're very likely to get an interview. Can you go on to work in F1 with a master's in DE? I certainly, not that I'm aware of, there are not any students that I'm aware of who have graduated from our department who have gone directly to work in F1. But there's absolutely no reason why you couldn't, because you have got all the engineering training and you're from Imperial College London. What you need to think about with F1 is, and with, for example, the concept of designing a car in general, is no one designs a car. You've got a team of thousands of engineers, some of whom will be designing a bolt or some of whom will be designing a nose cone or a steering wheel or a chair, okay, or a piece of a chair. Design engineers are more than qualified to design very many of the crucial components on a car, but they're, I would say, rather more likely to be involved in designing the steering wheel than they are with designing the high torque struts at the front of the car, because that's where more of your engineering discipline has been focused on. So that kind of human interaction with design and electronics and mechatronics and mechanical stuff, rather than just pure beam bending type activities. How much do you take the personal statement into account upon application? I know that some universities hardly look at them at all. We read them very closely indeed. And we are really looking for evidence of excellence and evidence of learning and evidence of sort of independent driven deployment of your skills. So we definitely read them and we definitely care about what they say. Is a graphical calculator required for the course? So not really, no. And the reason for that is that in some ways graphical calculators have become rather outdated. So you're very welcome to bring one along, but particularly for the maths course, but I think for most of our modules in general, we are driving towards keeping the open book paradigm that we were somewhat forced to use during the pandemic lockdowns. We think that's because open book exams are far more authentic to the real experience of being an engineer than classical closed book exams. How many trigonometric substitutions can you remember for integrating fractions was how the old maths exams for engineering have been for the past 60 years. Now it's, here's a problem, can you solve it using anything you want? And that is what it is to be an engineer. Are you able to look up the right things? That's far more useful than are you able to remember a subset of things that solve a subset of problems. So by all means, bring a graphical calculator if you like it, but there are far more powerful calculators built into your laptop and on the internet, which will be available to use. If you do FM, can you get an A star in that instead of in maths? Interesting question. Getting it instead of maths is quite a strange flex. I think almost everyone who can get an A star in FM could probably get an A star in M. But if you did do that, we would take it into consideration. But maybe, perhaps I've misunderstood your question, so feel free to drop us an email. Are personal projects, e.g. making small artifacts at home without entering competitions, favoured? We would love you to talk about them. During the interview, we will allow a few minutes at the end for you to show us some portfolio work, and that the interviews will be online, so you can show us physical objects, you can send us a link to a website that you've built, you can show us images from your portfolio, so things that you've designed, 3D digital design or sketches. All of these things will be wonderful for us to see and give us interesting insight into your passion for this topic. I want to know about the field of work that one would get to do in the automotive industry, having graduated from the undergraduate design engineering course. So I can't necessarily tell you. We only got 3 years of undergraduates who've graduated, so I can't say this student went to work here. But the automotive industry is an extremely broad space, as I was trying to make the point with the Formula One steering wheel versus nose cone design. And so in that space, there are, of course, systems, services, products, experiences, all need to be thought of in order to understand how to build an effective car that is a good product. And so perhaps, Amelia, you might have some suggestions as to things you might want to work on in the automotive industry with the skills that you have.
Yeah, I thought that I could speak on this for a bit. So actually, at the moment, I'm doing a 10-week internship just over the summer at Ocado Technology, which was mentioned before.
Fantastic.
And I'm actually working on autonomous mobility, which is obviously all to do with cars, self-driving cars. And so, you know, that's an in route. They saw the skills I have. They saw, oh, they're design engineers. They have this set of skills. They can do electronics. They can do design. We want to take them on. And it's not sort of, I want to say it's not so much the traditional F1, but you're still working with cars and what is realistically going to be the future of, you know, the automotive industry. And I guess with that, I've got the experience. So if I wanted to go on to work on F1, that would already give me, you know, an edge to go onto that. So absolutely, yeah, the skills you have really, they can get you jobs.
I've supervised 3 students who've done their placement at Ocado. I think it's fair to say that Ocado are obsessed with design engineering students. Partly because I think the first student that we ever sent there, Chris Turner, ended up with a whole bunch of patents just from his project, which was all about. Yeah, robots
Yeah.
that could sort of go around and up and down and then turn themselves around. Amazing stuff. So they were absolutely delighted, and they sent us an email saying, please send us more students, which is lovely. Okay. So I think we've now run out of questions, which is absolutely fine. Hopefully that means we've covered all the things you wanted to know during the talk. As I say, and as is visible in the chat, you are welcome to email us anytime, design.engineering@imperial.ac.uk, and we will get back to you as soon as we can. And perhaps with that, I'd like to thank Amelia and Hamza very much for your time today. And thank you all to those of you who've come online, and I really look forward to receiving all of your applications when you're ready. So thank you very much once again, and have a lovely day trying to stay out of the heat. Okay, take care. Bye-bye.